try. What is this? Okay, try again. So what you have to remember to keep in mind is this is your general or your basic sine function starts at 0, finish at 2 pi, halfway you're at pi, and that comes from your circle. If you remember the circle, when we start here at 0, the coordinate is 1, 0, and sine is the second coordinate. Between 0 and pi, you have pi over 2, and that's at 1, because on your circle here, pi over 2, the coordinate is 0, 1. And so on. So that's what you have to remember or keep in mind when we're going to be changing your sign. We're going to be stretching it, moving it, and we're going to do the same with cosine. Cosine is like the sine, but it starts at 1. Okay. Because again, if you remember on your circle, at 0, coordinate is 1, 0, and cosine is the first part. Okay, so if you're not sure about your graph, you can always come back on your circle. Starts at 0, comes back at 2 pi. That's what we call the period. We practice that. And here at pi, you're at the bottom. Halfway here, you're at the minimum, which is -1. And halfway between 0 and pi here, halfway it's pi over 2, you're at 0. So that's what you should keep in mind when we're going to do the cosine rule. And we're going to change the amplitude. Here, that's what we call the amplitude. The regular function, the amplitude is equal to 1, because in your circle, if you remember, we said it was a radius of 1. So that's your amplitude, but that's going to change. It can be stretched vertically or stretched horizontally. So let's see what happens when we start changing it. If I give you this, for example, to practice, so what you have to keep in mind is your sine is usually like this. This is your regular sine. If I want you to do 2 sine of x, what do you think is going to happen? Okay, this is going to change the minimum and maximum. It's going to be at -2 and 2. So instead of doing your graph, it's going to be more. Well, it's going to be the same here. This is still going to be 2 pi, but here it's going to be 2 instead of being 1. Right? So here it's going to be 2, and at the bottom, -2. That's what we call the amplitude. So we can say it's a vertical stretch. Okay? It's not changing the horizontal compression. The second one, if there's a negative in front of your function, what happens when there's negative? We switch, we reflect. Do we reflect on the x-axis or the y-axis? Okay, so this here shows a reflection on x-axis. So what is it going to look like? Instead of starting here and going up, I'm going to go down first and then back up. Is this still 2 pi? Yes. Is it still 1 and -1? Yes. Okay. It's just, instead of going up, it's going down. This one here, sine of 2x. This, Olivier said it before, when there's a number that's bigger, it's going to be a horizontal compression. And how do we do it? Is usually our period is 2 pi. But if there's a b, we're going to have to divide by our b. So in this case, if we have 2, our period is going to be 2 pi over 2, which is pi. So it means that when we do our graph, we're going to start at 0, but we're going to finish at pi. So where are we going to be halfway? Here. But what value here? Halfway between 0 and pi is what? Pi over 2. So that's going to be pi over 2. And halfway between pi over 2 and 0, it's pi over 4. So here at pi over 4, are we going to be at the top or at the bottom? But am I going up or down? Going up. Okay, so I'm going to be at 1 here. I'm going to start like this. And between pi over 2 and pi, think about your circle here. Okay, I'm at 0. This is pi. Halfway is pi over 2. Here is pi over 4. So this one is pi over 4 is here. Pi over 4, 2 pi over 4, 3 pi over 4. 3 pi over 4, and I'm going to be at the bottom then. Okay, and it's going to continue after. I'm just doing the first part, but it's continuing after. Sign of negative x. What's going to happen if there's a negative here? In front of your, if your p is negative. So if it was negative in front, it was reflection on the x-axis. When it's here, it's, yeah, it's a reflection on the y-axis. Okay, so when you do your graph, okay, you start at 0. Instead of going to the right, you're going to reflect and you're going to go to the left, right? Instead of going like this, I'm reflecting, so I'm going to go like this. What do you think? That's weird. If I keep going, look, if I keep going, what's going to happen? It's going to be like this, right? Oops. Imagine it's all at negative 1, right? So what do you realize here? If I'm going backward like this, it's the same as when I was doing the other one here. See? So it's just reflecting like this or reflecting like this is going to end up with the same curve. Okay. And so what happened if there's a reflection on the x and a reflection on the y? It comes back to normal. Because if you reflect like this and you reflect like this, then it comes back to our original sign of x. Okay? Yep. This is my reflection on the y-axis. Because instead of going that way, I'm reflecting, so I'm going that way. But really, it ends up the same as here. So if there's a negative in front of sign and the negative in front of x, they're kind of canceling each other. Because you're doing a reflection like this and reflection like this. Oh, phew. Okay, so here, what do you see? Translation. Is it going to be to the left or to the right? If it's negative pi, it's to the right, remember? Because it's x minus, it's always the opposite. So translation to the right. Okay. So when you're doing your graph, instead of starting at 0, where am I going to start? Instead of starting here at 0, I'm going to start at pi. Okay, so where it says pi here, I'm going to start here. So if I end up, oh, wait. Sorry. So translation to the right. So instead of starting at 0 here, I'm going to start at pi. Where am I going to finish if I start at pi? Instead of, so usually we start at 0, we finish at 2 pi. So if I start at pi, I'm going to finish here at 3 pi. Because I move everything by 1 pi. And halfway in the middle, it's going to be 2 pi. I'm going to be back here. And what's the middle between pi and 2 pi? If you're not sure, you can go back to your circle. What's the middle between pi and 2 pi? Here, what's the middle between pi and 2 pi? What is this point again? Good. So between pi and 2 pi here, you have 3 pi over 2. Oh my god. You know, here, 3 pi over 2. And am I going to be at the top or at the bottom here? At the top, because there's no negative, right? I'm going to be here at the top at 1. So I'm going to go back up here. And between 2 pi and 3 pi. So between 2 pi and then 3 pi would be here. But be careful, it's not pi over 2 because that's pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. So here in the middle, it's going to be 5 pi over 2. Am I going to be at the top or at the bottom? At the bottom, because we need to respect our curve. And then you keep going. So you would have to go backward 2 pi here, and then halfway, and then you would continue your curve like this. But try to do at least one part of your curve, and then after you just continue on both sides. And the last one, what's going to happen on this one, sine of x plus 4. It's a translation on, it's a translation right, left, up or down? Up. Okay, so instead of doing, usually your graph starts here at 0, usually we'd start, so now we're going to start 1, 2, 3, 4. We're going to start at 4. Imagine your sinusoidal axis is here. I'm going to start here. I'm going to go, where is my next point? Yeah, it's the same as the basic, so it would be where? 2 pi, good. So at 2 pi, I'm going to be here. Halfway, where am I going to be? At 5, so I'm going to be here. And then halfway between these two, I'm going to be up. Now, where is it going to be up here? At 5, good. Because it's 1 up and 1 down. So I'm going to be in the middle here, I'm going to be up. And in the middle here, I'm going to be down. So you start with your first curve like this, and you continue on both sides after. So we covered the amplitude, the period, the translation H and K, horizontal and vertical. So I think we covered them all. Right? So let's see now if you have to graph one. Okay, so maybe we're just going to write down in our notes. I'm not sure if you had time to write it down, but just write down. So this is our original curve. Just write down that this here, we call it the amplitude. And how do we find the amplitude? How do we find this measure? If, let's say, we have the maximum here and the minimum here. Okay, this is our max here. This is our min. So if I have 1 and negative 1, how can I find my amplitude? What do we do with them? We add them or we subtract them, or what calculation can you do with the 1 and the negative 1 to find your amplitude? If I add them up, is it going to work? If I do 1 minus 1? No. So if you subtract, you take your maximum minus your minimum. But that's going to give you the whole thing. What you have to do after? Divide by 2. Okay, so if you want, you can also write, we can calculate by doing the max minus the min, but then divide by 2, because otherwise you would have 2 amplitudes. Okay, and that the amplitude in our formula here is going to be our A. But it's going to be absolute value of A. Why is it absolute value of A and not just A? Because if you have, let's say, minus 2, the amplitude cannot be minus 2. It's only 2. The other thing that's really important is this way. That's what we call the period. And the period is usually 2 pi, but we're going to divide it by B. Absolute value of B, because we don't want to find the reflection that would change our value. The period is also always positive, cannot be a negative period. After that, we have the axis that's kind of here in the middle. Okay, that's sinusoidal axis, and that's our k. It's our k value if it goes up or down. I suggest you trace it in dotted line so that way you see it. And the other thing that's missing in our formula is h, or h. Okay. H is our starting point. Okay. It's the x value of the starting point. So I decided to use this one. Could I use this one for my starting point? Yeah. But then I would have a 2 pi here. So it would be minus 2 pi. So you can repeat it as many times as one on the left or on the right. Usually we take the point that's closer to 0, 0. Just so we all have the same answer. But we can take whatever h we want. Well, the period here, yeah, it's the same. But the period, if you look at this, it's 2 pi. But if there's a b here, if let's say there's a 2, then you're going to do 2 pi over 2, and that's going to give you your period. Your period is going to be pi. You're going to get stretch or compression. Yeah. This one? Well, no, it's really small here, but that says pi over 2, pi, 3 pi over 2, and 2 pi. So if you look at this graph, the period is this, and therefore it's 2 pi. Okay? But if we use this formula and we do 2 pi over 2 pi, sorry, if we do, because you look here, our b is 1, right? So if we put 2 pi over b over 1, we get 2 pi. It's just when we use the formula here that you're going to use this. When you look at your graph, the period is this. Here is the x value of your starting point. We decided that our starting point was here, but like I said, we could have decided here or anywhere back and forth. Okay, so let's try to graph one. See if we're good. Let's try this one. So first, when you look at it, is it in the right form? That's the first thing you have to check. Okay, make sure you check that first. It's not even in the right form. So how do we factorize here? So 3 sign is okay. But here, what do we have to factorize? Your x, like the value in front. So we have to take out the x. So here. Now, what are we going to put here? If you're not sure, you show your calculation here. I have pi over 2 that I need to divide by 2. Because I'm taking out 2. Right? So if you take this, how can you divide by 2? 2 is the same as 2 over 1. So you can multiply by the reciprocal. So you get pi over 4. And I suggest you do this calculation on the side to make sure you factor correctly. Because if you mess up on your factorization, then you get your thing wrong. Okay, good. So that's our function. So I'm gonna. What should we start with? What do you think we should start with? What? Okay. Well, you have to remember that when we're doing usually our graph, we go like this, right? But it goes around our k. So make sure you pay attention, okay, to your k. I think that's probably should be one of the first thing we do, because if we start graphing at 0 and then after, oh no, there's a k. So k here is what? Is 5. So you're gonna need to add your sinusoidal axis at 5. So if I'm using this graph here, I can go by 2 maybe. So 2, 4, 6, 8. At 5, I know I'm gonna have this axis here. Okay, what else? Okay, B is what? It's helping us for what, B? The period. Okay. Okay, let's check check the period. The period is 2 pi over b, so 2 pi over 2, so pi. Okay, we have our period, but we don't know where to start our graph. So can we find our starting point? Where? Okay, we know here our h is pi over 4. So that means I'm going to have to start at pi over 4. How do you graph your... well, I can decide, okay, I'm going to decide this is pi over 4. So I'm going to start here. If I start here, where am I going to end my first thing? If I start at pi over 4 and my period is pi, where am I going to end? You can calculate that, right? Can you do pi over 4 plus pi? Can you add fraction? What do you have to do? So this one, what do I need to do? Put it over 4. So times 4 times 4. So pi over 4 plus 4 pi over 4. 5 pi over 4. So if I start here at pi over 4, this is 2 pi over 4. You can write it like this if you want. Maybe some of you will say, well, 4 pi over 4 is the same as pi. That's okay. 2 pi over 4 is the same as pi over 2. You can do that too. So I know at 5 pi over 4 I'm going to be here. What else we need? Oh, we need to check if there's reflection or... Is there any reflection? No, so make sure you check. Yeah. There are reflections. No, because there's no negative. Did we use all the numbers in our formula? What we need to use? Oh, min and max. So we need to check with our A. Here. This tells us that our amplitude is 3. So what is the max? Why 9? Really?
Oh, no, it's not.
Oh, April Fool. Okay. And what's our min? We start at 5 and we go down 3. So 2. Okay, good. So we know that between here pi and 5 pi over 4, halfway is here in the middle. So we already know these 3 points. And we know halfway here is going to be where, max or min? Between these two, are we going up or down? You're going to the maximum, which is 8. And between these two, you're going to the minimum, which is 2. So, graph here. Should I stop like this? I need to go on, right? So if I want to do the next one, I need to count 1, 2, 3, 4. And I'm going to be here. Halfway, I'm going to be here. Halfway, I'm going to be here. And I can continue. And if I'm going backward, 1, 2, 3, 4, I'm going here. And then halfway, I'm coming here. And halfway, I'm going down. So you always have to use halfway. That way it's really simple. You're making nice graphs. And you can continue to always use the fact that there's 4 sections in our graph. So 1, 2, 3, 4 here, halfway here, halfway here. Okay, so you can make nice graphs. Does it look too hard? Yes, no? Okay, I'm gonna give you some time to try this one by yourself. Just gonna stop the recording for a second. Okay, so when you start, first make sure you put it in the right form. So your 3 is out, so you're gonna have this. What is the first element that you wrote? Yeah, I think you should start with this first. Huh? You know your k is equal to 1, so if you go to 1, you know your axis is going to go around here, your sinusoidal axis. Okay? Then the period, okay? So if you find the period, The period is 2 pi over b. So b is 3, 2 pi over 3. Good. Then are you able to graph that? No. Okay, so let's look at the starting point here. Our starting point is at when x is equal to pi. So we're going to start at pi. Where are we going to end? Pi plus or period 2 pi over 3. Can we add these two right now like that? This is here over 1 and this is over 3. So we need to find a common denominator. If we times by 3 here, times by 3. So we know 5 pi over 3 is going to be our ending point. Okay? So I can come and graph that if I want, but I need to put my graduation here. So I'm going to graduate in pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi. Okay, now I have my starting point here because this is the same as pi. So I'm going to start here and end here. Okay, halfway, where should I be? I'm going to be here, halfway. And halfway between these two, I need to be at the max or at the min? At the max because there's no reflection. Let's look in number 4. Let's find the max and the min. What's the max? It's 1 plus our amplitude plus 2. 3. Okay, so I'm going to write it here. Our amplitude is equal to 2 because that's our A. So then we find the minimum. 1 minus 2 is minus 1. So we know here we're going to be at 2. Well, sorry, 3. We have our 3 here. And halfway here we're going to be at the minimum at negative 1. So we're able to graph here. Okay. If we want to know what's in the middle of pi over 3, think about your circle here. That's pi over 3. What's in the middle here of pi over 3? Pi over 6. Good. So you could have decided also to graduate in pi over 6, and that way you would see these graduation here on your graph. And then you have to go backward. Okay, and you do the same thing. Halfway you go to your minimum, halfway you go to your maximum. And you're able to graph backward. Good. Okay. Next, we're going to do the same, but with the cosine. I did. Yes. The next thing we're going to do is the cosine, which is almost the same, right? What do you have to remember about the cosine? It starts here, finishes here. Do you see the sinusoidal axis? Now the only thing here is, look, it's not your starting point on the sinusoidal axis. You have to start here, start at max. That's the most important thing for this one. You have to remember we start at the max. One period after, where are we? At the max also. The period is again 2 pi over b. And it's absolute value of b because it doesn't matter if we have reflection or not. Where is the amplitude? Sebastien? Focus. Where is the amplitude? Yeah. It's from the dotted line to the maximum, or can it be at the bottom too? Yeah, it can also be this. The amplitude. How can we figure it out if we don't have the graph? How can we figure it out? Max. Don't forget to divide by 2 because otherwise you're going to get all the value. What else do we need to know? So we talk about A, B, K, or this is our K, right? Y is equal to K. And our H, okay, H, we have to start at the max. That's the most important thing. Okay, we're going to take the break and continue after. Yeah. Okay, let's try this one. What's the first thing? Yeah, yeah, that's it. Like the same. It's about the same thing. The only difference with the cosine, you have to remember, we start at the max instead of starting in the middle. Okay. So what's the first thing we should do when you look at this rule? Yeah, like we need to factor. Did I factor? I did. Oh, nice. So we're ready. Okay, so this is our A, cosine of B, x minus h plus k. Okay, so what should we start with? Your k, huh? Your case. It's still, yeah, because you realize it's the same curve, right? It's just really moved a little bit. So we call it usually the sinusoidal curve anyway. So we start at 5. But what's going to be our max? So we know that this is our, okay, and we know our amplitude. Amplitude is what? No? 10. Okay, so then the max is going to be 10 plus 5, so 15. And the min, so 5. So we have to go all the way up to 15. So let's go by 5. Okay, 5, 10, 15, 20. We don't really need 20, but we know. So now we know our k. Yes, I did the opposite. Oh my god. So let's try that again. Yes, because sorry, we start at 5 and we go down 10. You're right, negative 5. So we have to go from negative 5 to 15. Okay, good. So our 5 is our dotted line. Okay. Then where do we start? The period. Okay, so if we find the period is always 2 pi over b, or b is, oh, there's a negative here. What does it mean if there's a negative? Here you have to be careful. What does it mean? It's a reflection on, okay, reflection on y-axis. So when we start, instead of going to the right, we're going to go to the left, right? Okay. Is it going to change something? Look at this. If we reflect for the cosine, does it change anything? No. See? That we start here or we start here is the same thing. So this one, there's a negative, but you see it's going to be the same way. Okay, so what else? We found a period. 2 pi over 2. When we divide fraction, we multiply by the reciprocal, 2 over pi. So then we get 4 pi over pi, which is 4. Okay, and our start, we're going to start at h, which is 1. So we're going to start at 1, and the period is 4, so it's going to end where? End at 1 plus 4, 5. Okay, so can we graduate by 1? 1, 2, 3, 4, 5. Okay. So when we start at 1, we start at the maximum or the minimum? At 1, we're going to start at 15. And we're going to end at 15 also. But we said there's a reflection, but if there's a reflection, 1, 2, 3, 4, it's going to be the same thing. Okay. Halfway, where are we going to be halfway? 1, 2, 3, 4. But 1, 2, 3, like we're doing four parts. Okay. Halfway between my 2 points, where am I going to be? Yeah, but where? At the minimum. Good. So I'm going to be here at the minimum. And halfway between my 2 here, I'm going to be on my axis. So that's how you should do it. Always go halfway. That way it gives you a nice graph. And if I'm doing it backward, halfway I'm going down, halfway I'm in the middle. It's going to be like this. So now you're just going to need to practice. Make sure that you put things in order. The next one. Okay, this is just a resume. I'm going to leave it there. I don't know if we can see it, but it's just what you have in your it's coming out of your book. I just want to show you if you want to find more information. It's in your book. Okay, the parameters is all written down what we just did. So there's not much you need to write. And again, to review just a few steps. Okay, I talked about it, so I think you should be okay with this one. Good. So we're gonna start with that. I asked you to do it without your calculator, so you're not, you don't really need it.